Okay, let's learn now how to do related rates problems step by step. 1. Draw the diagram. To understand each word problem, you should draw, you should visualize what is going on over there. Okay, so you gotta draw. 2. Read the problem and write. Find when given. Okay, we need to identify what to find, which related rate we need to find. When that happened, if it is saying that at the time, at the second, third second, or when minute is equal to 5, okay, so when is that happening? And what else is given? Okay, sometimes it says that at that particular time, the some other rate is given in this minutes, inches per minute, kind of stuff, with the appropriate information. Third step, we write the relating equation. Okay, it can be equation in terms of tangents, maybe volume, equation of the volume, anything. We'll check it. And find the derivative of both sides. We've got to take the d over dt of the given equation, or the equation that we identify. Okay. And we've got to substitute given and when, then we can solve it for fine. Let's continue with the equation. Here we have a equation. This question says the top of a 25-foot ladder is sliding down a vertical wall. Okay, I tried to draw this picture to visualize. When you do it on your paper, you don't have this much, you don't have this much bricks. Okay. But you can simply visualize that from the side. When you look at it, you can identify the height. This is the height. Okay, and this is the distance of the bottom part of this ladder to the wall, and you can pretty much identify this is going to be a right triangle. Okay, so when you start to draw the picture, it's going to give you lots of clues. Let's see, what do we have? What is given? 25-foot ladder. So just write down 25. Will this height of the ladder, the length of the ladder is going to change. Let's understand from here to here, the ladder's length is 25 foot. What is going to happen is sliding down. Okay, this part is going downward. Okay, since the ladder's length cannot change, this part is also going outward. It looks like somebody from here is falling down. It is very difficult situation, dangerous. Yeah, let's see the accident, how it happens. Okay, let's understand the math behind it. Okay, never try this. Let's see. It is sliding down a vertical wall at a constant rate of 3 feet per minute. Okay, we have a rate is given here. Okay, change in height over change in time is given here as 3 feet per minute. Okay, let's keep working, let's keep jotting this information, okay, step by step, to understand what's given, what to find. Okay, when the top of the ladder, see, when is what? The top of the ladder is 7 feet. When the h equals 7, when, just please write it down here, when h equals to 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder, which is here, and the y, which is here. Oh, it is asking this. X. What's the rate of change? Rate of change. This is about the derivative. Change of x, rate of change of x, which is dx per what? Rate of change of the distance, of course, it's going to be per time, yeah? dx of dt is asked. Okay, let's try to understand. Let's see this information. We have right triangle. So, if you have a right triangle, what you need to remember is Pythagorean theorem. Let's directly write down that theorem here. Okay. Pythagorean theorem says on this triangle, h squared plus x squared is going to be equal to 25 squared. Okay. dx over dt is given. Oh, no, we gotta find this one. Okay. And dh, write down this in small way. dh over dt is given, okay? And h is given, with the only find dx over dt. One thing is important. When the ladder is something like this way, okay, while the h is equal to 7, let's try to understand what is x is going to be. Okay? What is this length is going to be? Okay? Let's see. Just put the 8, just plug in h equals to 7 here, and try to find h, or x, 7 squared plus x squared equals to 25. To find x squared, let's do this math. X squared equals to this 25 squared. 25 squared minus 7 squared. Where you have x squared equals to 625 minus 49. Where you are going to have 500. That's going to be 76. Correct. What's that x squared? Which number squared is 576? If you do your math, do the mental math. This is going to be 24. Positive, negative 24, but think meaningfully. Can a distance be a negative? Of course not. That's why x is going to be 24. So, when h equals to 7, x is going to be equal to 24. Now, are we done? No, we need to find change of x over t. Okay, rate of change of x with respect to time when h equals to 7 and x equals to 24. Okay, let me clear this around and let me work on the clean array. I need this equation, I need this given data, I need this. Okay, I need anything else. I already used this picture. So let me clear. Let's clear this array. Okay, so I'm going to this one. Let's do this. Okay, we have some things. Okay, good. Let's take this derivative of what's given. Need to go back. I'm trying to do derivative of given relationship over time. So let's do this. Derivative of this equation, x squared plus x squared equals to derivative of 25 squared over dt. What you have here is h, remember, h and x are functions in terms of time. So we can distribute this. which is going to be dh squared over dt plus dx squared plus dt equals to, this is constant derivative over, well, with respect to any variable is going to be 0, because constant does not change. So rate of change of unchanging thing, anything is going to be 0. Let's continue. Here we have 2h times dh over dt plus we have 2x times dx over dt equals to 0. Let's plug in what we know. We know that h is 7. H is 7. So plug it in here. 7. dh over dt. Here it is. dh over dt is given here. It is when the top of the ladder is 7 feet. No. When it is sliding down a vertical wall, a constant rate of 3 feet per minute. So the change of height per time is going to be 3. So this is going to be 3 times 3. And what is this x is going to be? X is going to be 24. Just got it from here. 24. Do you know anything else? No, we need to find this one. This asked here. So let's put this others. Okay. 2 is here. We have it from this derivative of h squared plus we have another 2 here. It's coming from h squared, x squared. 2 times. And you need to find derivative of x. Let me use this easy, simple notation equals to 0. Okay. Do you know what? One thing we have forgotten. This 25-foot ladder is sliding down. Movement to the down needs to be shown by a negative number. So we have to use this negative sign here. Okay, so this is going to be negative 3. Nobody is telling this to me. So negative 3, don't forget that. Let's solve this equation. Okay? Now, I'm not finished this, but you can finish it. Okay, let me finish it. 2 times 7 times 3. What? 14? Oh, 14 times 3. 42. And we have negative sign, negative 42. Plus 2 times 24. 48 times x prime equals to 0. Okay. One reminder, but that's alright. We can solve this here. X prime is going to be then. Move this on the other side, divide by 48, so you'll get 42 over 48. Simplify both sides by 6. You'll have 7 over 8. 7 over 8. With respect to what? Change in length per time. What is our length is in? It is in foot. So let's put that here. 7 or 8 foot per, what's the time in? It is in minute. Per minute. Alright, we are done. Thank you for watching. See you next.